Okay, so the Unit 1 benchmark study guide. So for number 1, your first step would be to add 7 to both sides. So if you take the 7 and you add it over, you would have 4. Absolute value of 2x plus 3 is greater than or equal to 28. Your next step is you would want to divide both sides by 4. So if you divide both sides by 4, you would have the absolute value of 2x plus 3 is greater than or equal to 7. When you're solving an absolute value, you should get two answers. So you want to take what is in the absolute value set and set it to 7. So 2x plus 3 is greater than or equal to 7. And you also want to take the same exact thing, 2x plus 3. You flip the symbol and set it to the negative. So solving each one of these, you would subtract 3, which would give you 4, and then divide by 2. So x is greater than or equal to 2. And on the other side, if you subtract 3, that would give you negative 10. And negative 10 divided by 2, x is less than or equal to negative 5. If you were to put these on a number line, we'll call this 0 in the middle, you would want to find negative 5 and 2. And in this case, it's greater than or equal to 2. So it's going closed dot to the right, and less than or equal to negative 5. So closed dot to the left. For number 2, they give you an equation and they ask for the increase and the decrease. To find the increase and decrease, you should look at this on a graph. So it's an absolute value, so you know the original shape is a V. The negative out front turns this into an A. There is no left and right shift, and it's up 5 units in the air. So you'd want to go up to 5. And again, since there's a negative out front, it turns it upside down. The question asks for the increase and the decrease. This was taught with the guy that runs from negative infinity to infinity. So as the guy starts to run, the graph is increasing, it's going up, and it keeps doing so until this guy has ran to the center, which would be x is equal to 0. And then from 0 to infinity, the graph is going down. So to write this, we put an x in the middle, turn the symbols to the left, and to recap, we said he starts to run from negative infinity, and he keeps running until he has got to the center, which is 0. And then the graph turns around and the decrease begins from 0 until infinity. For the third one, it asks for the domain and range of the graph. The graph is an absolute value. It's been shifted 4 units to the left. It's a V, so 4 units to the left. There's nothing on the back side, so there's no up and down. So this would be your graph. And it's asking for the domain and the range. Domain is your x values, so the domain is all real numbers. The range is the y values, so the y values begin at y is equal to 0, and then everything that is above that. So for your range, we would say y is greater than or equal to 0. Okay, for number 4, it's asking for the end behavior. So this is going in 2 directions. You want to know what happens as x goes all the way to the right, and also what happens as x is going all the way to the left. So to write this, you want to say as x goes to the right, which is written as x goes to infinity, y goes, so as x is going all the way to the right, you follow the arrow, and the last thing that this graph does is it's heading down. To say down, you would say negative infinity. The other way around is as x goes to the left, we want to know where does y go. And in this case, as x goes all the way to the left, y values are going up. So we would say y goes to infinity. Okay, for number 5, they want you to graph the following. So you look at the graph of the function, you see that it's a V, 3 to the right, 2 up. Then you also look and you say that it says less than or equal to. So since it's or equal to, it would be a solid V. And since it says less than, we want to do shading. We want to shade below the graph that you make. So you would have 3 to the right, 2 up. You're going to make a solid V. And again, since this says less than, we're going to shade everything that is below. If it had said greater than, we would have shaded everything that was above. Number 6 is a variation question, and in this one there's 2 different types of variation happening at the same time. It says that the time needed to build a house varies directly with the size and inversely with the number of people. So the first thing you want to do is select letters that make sense to your problem. So if they're talking about time, it says the time varies. So t equals, it varies directly with the size of the house and inversely with the number of people working on it. So directly with the size is k, and we'll use s for size, and inversely with the number of people is over p. So you keep reading, and it says that if it takes 50 hours, so that would be t is equal to 50, so 50 is equal to, and then k is what you want to solve for, and then it says the size of the house is 400, and the number of people working on it is 16. So first thing you want to do is solve for k. We'd multiply both sides by 16, that gives you 800. We would divide our 800 by 400, and that gives you k is equal to 2. Now that we know that, we can go through and answer the question. So we start with our same formula again. Time equals ks over p. It says now that we know this, how long would it take 8 people to build a 1,200 square foot house? So time is equal to k, but we know k, it's 2, times the size of the new house is 1,200 over 8. You do that math. 1,200 times 2 is 2,400. 2,400 divided by 8, t is equal to 300, and it would be 300 hours. For number 7, the first step here is that you want to subtract 7. You have to make sure that you understand that this is 7 plus. So if you want to undo this, you want to subtract 7 from both sides. And that would give us the absolute value of x minus 1 is equal to 5. It's an absolute value problem, so we're going to get 2 answers. So we're going to say x minus 1 is equal to 5, and x minus 1 is equal to negative 5. To solve these, you want to add 1 to both sides. So this would be x is equal to 6, and x is equal to negative 4. For number 8, they just want the equation of this graph. So you look and you identify its shape first off, and you see a v. You should be thinking absolute value. So you want to say y is equal to, and then you say, well, what's happening with my v? It's 3 units to the right, so that's x minus 3. Remember, it's always the opposite for the left and the right. And then you want to go down 2 units. You do exactly as you see for the up and the down. So again, it's an absolute value symbols because it's a v. To say 3 to the right, we're always thinking the opposite of what you see. So to go positive 3, it's going to be x minus 3. That's the opposite. And then to go down 2 units is minus 2. Okay, to do number 9, it's solve the absolute value. So we're looking for 2 answers. We should say x minus 6 is greater than 2. And we also should say x minus 6, flip the symbol, negative 2. So we want to solve them both. And we would solve them by adding 6. So we would say x is greater than 8. And we would also say x is less than, if we add our 6 over, it would be 4. So now we need to look at our multiple choice. So obviously B and C are gone because those only give you one answer, so those are no good. So now when we look at choice A, it says if we cover this part up here, it just says x is greater than 4. So when I look at this one, this does not match. This doesn't say x is greater than 4, it's x is less than 4. Same thing with the 8. If I covered it up from this side, it says x is less than 8, whereas over here it says x is greater than 8. So D is correct, but let's look why. So this one says individually x is less than 4. That matches here, x is less than 4. And the other one says x is greater than 8. So that one is x is greater than 8. Answer you want is choice D. Problem number 10 says y varies jointly with x and z. If y is 56, when x is 4 and z is 7. So first off, we need an equation. So y varies jointly with x and z. Next part, we want to find k. So we keep reading. It says y is 56 when there's our k, and when x is 4 and z is 7. So we put in our 4 and our 7. We're trying to solve for k. 4 times 7 is 28. So this is 56 is equal to k 28, or 28k. Divide both sides by 28. Goes in nicely. Twice k is equal to 2. That's not our answer, though. That's just what we need along the way. Answer to the question is find y when x is 16 and z is 3. So you keep reading. We know k now. K is 2, x is 16, Z is 3. You multiply them together. 2 times 16 is 32. Triple that, and you got y is equal to 96. Okay, number 11a. It's a fifth root problem, and for a fifth root problem, you need a perfect fifth root, and the only perfect fifth root we have is 32. So you would want to write this as 32 times 7. Bring the letters down, a to the fourth, b to the fifth. And since it's a fifth root, you ask yourself, which one of these numbers could you take the fifth root of? And that one would be 32. And the fifth root of 32 is 2. Leave some space. 7 is stuck underneath. You can't take the fifth root of that. To do the letters, you look at the 5 in the corner and ask yourself, how many times does 5 go into each exponent? 5 does not go into 4, so that would stay underneath. 5 goes into 5 once, so there's a 1 right here. There's no remainder, so there's nothing left. This is your final answer. For number 11b, it's the fourth root, and you start looking at your fourth root list, so your choices would be 1, 16, 81. You start trying to see which one of these numbers would go into 405. It ends up being 81 times 5. So this is the fourth root of 81 times 5, x to the 16th, y to the 5th. So you say, what is the fourth root of 81? And the fourth root of 81 is 3. Leaves you the fourth root, and the 5 is stuck underneath. To do the exponents, you say 4 goes into 16 how many times? That would be 4 times without a remainder. 4 goes into 5 how many times? That happens once. Remainder 1. Final answer. For number 12, part A, we want to be careful with the numbers. In this case, it's a square root. 25 is a perfect square, so we can take this first off. So 25 turns into a 5. And you want to go really slow because the number in the corner is still a 2. And you still want to run the same process. 2 goes into 9 how many times? And that's 4. Remainder 1. And 2 goes into 49 how many times? And that would be 24. Remainder 1. So you want to be careful not to do this. You would have 5, and you might get confused because you would see perfect squares. You would not want to say that. The process still follows every time. So you take the square root of your number, index number into the variable, how many times outside, remainder underneath. So for number 12b, you want to go slow. 256 might be a bigger number than you're used to. If you play with it in a calculator, you discover it's on your perfect square list in the same manner as 4, 9, 16, 25. The square root of 256 is an even 16. And then for your letters, 2's in the corner. 2 goes into 5 twice, remainder 1. 2 goes into 16, 8, no remainder. For 13, A and B, we'll look at them at the same time. It's asking for the vertex. So in each case, the vertex is going to be, in this one, 2 to the right and 6 up. So your vertex is 2, 6. And in this one over here, your vertex would be -3, -5. So the vertex is just the starting point of your graph. It's where you shifted everything. The negative out front would turn your graph upside down, but you would still have the same starting point. So again, in this one, it's 2 to the right, 6 up. You're always doing the opposite for the left and right. For this one, same thing, but 3 to the left, 5 down, and we said the negative out front. The only thing that changes is the direction that your graph's going, but it would not change where your actual starting point is at. For number 14, we want to find the increase, and you are looking at an upside down U, which we know because it was something squared and there was a negative out front. So if we were to graph this, we would be 2 to the left, we would be 1 up. So 2 to the left, 1 up, and it would be an upside down U. We want to find the increase. The increase would go from, the guy starts running at -infinity, and as he starts to run, this graph immediately goes up, and then it goes down. So the increase is from -infinity until -2. For number 15, we want to factor the following. It's 3 terms, so you know the answer has to look like this with 2 sets of parentheses, and we start thinking about FOIL in reverse. So I know that first times first has to be 5x squared, meaning 5x and x, and I know last times last has to be 8, so it could be 2 and 4 or 1 and 8, but we start looking and we see what we want to make in the middle. We want to come up with an 18 in the middle. If we go with a 4 and a 2, 2 times 4 does get me to 8. I start looking. The outer and the inner is what makes the middle. Currently the outer is 20, the inner is 2. We're trying to make this a negative 18, so we want our 20 to be negative, our 2 to be positive. For 16, it asks for the end behavior. If you do not recognize the shape, you would go to your calculator and graph this. But if you see that it's something with x squared and a negative out front, we recognize x squared to be something in the shape of a u. If there's a negative out front, it's something in the shape of an upside down u. So without using your calculator, you're not entirely sure where this upside down u is. But in this case, it's only asking for the end behavior, so all you need to know is the direction that it's going. So for each of these, as x goes to the right, also as x goes to the left, the y values, which you can write as f of x or as y, would both be going down. Okay, for number 17, it asks for the interval of decrease for each. So to do that, you want to have an idea of what each graph would look like. So they're all square roots. So for every graph, you should be thinking about an arc. So we're going to make 3 graphs. For the first one, it's 1 to the right and 3 up. 1 to the right and 3 up. That's our starting place. There's no negative out front, so it is just an arc. For our second one, it's 6 to the left. There is no up and down. There's a negative out front, so our graph would go underneath. And for the third one, for C, it's 2 to the right. It's 1 up. There's a negative out front. So now we have 3 graphs. For each one, we're looking for the interval of decrease. In the first one, this graph is increasing at all times, so there is no decrease, so your decrease is NA or none. For the second one, looking for the decrease, and the decrease starts when x is negative 6, and it would continue all the way to infinity. So to write your decrease, you would say from negative 6 and to infinity. And the last one, the decrease, it always starts at the x value. So in this case, it starts at 2 and continues on. So the decrease is from 2 until infinity. For number 18, they gave you 3 graphs, and they wanted to know the domain of each. Domain is x over the period of forever. So we're looking at the first one, and you're looking at the snapshot of it. So from negative 4, this graph would keep going and going and going and going. So in terms of our x values, my domain would be x is greater than or equal to negative 4. For the middle one, again, looking at what all the possible values that x could be over a long period of time. It starts here when x is 2, and the graph is heading to the right, so our domain is x is greater than or equal to 2. Same story for our last one, but you want to be careful now because the x value we're interested in is x is 0. Negative 2 is the y value, so the domain would be x is greater than or equal to 0. For 19, you need the equation for each. For the first one, it's a radical. It's an upside down radical. So to write this, we would say y equals, it's upside down, so we need a negative out front, radical, and it's 1 to the right, so x minus 1, and then plus 2. For the second one, it's a u shifted 2 units down, so y is equal to x squared minus 2. If you want to put the x in parentheses before the squared, that would be fine, but optional when there's not a left and right shift. For number 20, we want to factor. It's 2 terms. So when you're looking at 2 terms, you want to ask yourself, do you see squares, do you see cubes, or do you see stuff? In this case, it's 2 terms, and they're all perfect cubes. So to factor that, you have to know the pattern. And for the symbols, we say SOAP. SOAP meaning same, opposite, always positive. So the same symbol, the opposite symbol, always positive. To factor cubes, you take the cube root of each. So that is 3x and 1. Square the front is 9x squared. Square the back is 1. Multiply them together, and you've got 3x.